Well, looks like we're alive. Well, hi there, friends. Guess we're alive. Yeah, excellent. So today we're gonna go and what are we gonna do today is that let me change my screen first. Writing, adding new hardware to OpenRGB. Alright, we're gonna add the soundcast to microphone to the OpenRGB. So my friend has that microphone which has some problems with the brightness of the microphone. So here's the repo of OpenRGB. I guess I just cloned it. Let's go with src. No, it didn't clone it, sorry. So clone, cd src, clone and clone again. So I'm in the Celestia Linux and the permission is denied. Well, I guess I'm just gonna stick with HTTP then. RMRF open. What do we have? Let's clone it again. I actually have a repo here and the OpenRGB quadcast too, but it was not working fine. So we're gonna start back again because I don't want to deal with that. Whoops, sorry. Let's go here and let's select it. Let's open it. So I'm going to install. Is there anybody in the stream now? Or I'm gonna add. Wait a minute. Alright. I don't know how this stuff is working, but yeah, I don't know how I did that. Never mind. So I'm gonna add C++ extensions, which we don't have that. Well, that's kind of interesting. So I guess we don't have any extensions to work on. But I guess we don't have that. We don't need that. So in here, where we are gonna go? We are gonna go into the controllers, and we're gonna find the HyperX mouse. What? HyperX microphone V2. Right, it's probably Quadcast 2S microphone. So it's 2S. I guess they added. I don't know. This stuff got updated. I want to see it. Let's work on that. Controllers. And let's go to HyperX. So wait, they added this. Do we have that as well? HyperX must be. Yeah. We have that. So where did we add our stuff? Firstly, I want to see it. Let's go to latest comments. Here. And we don't have any comments in there. Guess I didn't add any comments. Well, that's a shame. No, that's great. Oops, I closed my stream. We gotta go back there. Yeah, it still works. Alright. Now, right. Let's put an ad on thing. That's a shame. Let's go to there. So we have HyperX microphone controller. Where is the supported devices? I want to see it first. Are they really added? OpenRGB. Let's go there and do supported devices. Alright. Where is the supported devices? Seems like we can't find it. But firstly, maybe we should work on getting a HyperCast 2 microphone within ourselves, because I don't have the original hardware. So how we're gonna do that is, you might ask. So we could just go from here, or just open another console and go here and go into my other repository, which is the Quadcast 2 Linux driver. Let's go in there and let's copy with the SSH key. I need to create SSH key keygen help. What do we have in here? Go here and Codeberg SSH key. See how we can add that. Right. Let's go in here. Yes. So we have that, and let's copy it. Go in here. Go to settings, SSH keys, and add Arch. Right, that's great. We added. So let's go back in here. Alright. Now let's clone it. So git clone. Just open our folder. Yes. Somebody came into my stream? No. Alright, so what do we have in here? Let's close here and how can I close in here? Hello, I want to close the chat, bro. Yeah, just never mind. It's gonna stick on there, I think so. No, I don't want you. I don't want you. No. No, get off. Never mind. So we have driver and emulator with gadget 2 is actually, we're gonna talk about that. So in phrases 1, we have some information from the original hardware, which I think that the Arch version of code really sucks, but can't do anything about that. So we have informations from the real hardware. Settings, GSend, mouse, so I set it that the HTRL listing, and we actually have some devices over here. So that's what we are gonna looking for in here. The bus 9 and device 0. This is the ID of the HyperX Core Quadcast 2 controller, which it has an interrupt pointer, I think so, yeah. We have an interrupt pointer over here, the endpoint descriptor, and we also have some of the interrupts in here as well. So the analysis is over here. So we have the vendor ID, product ID, interfaces, and endpoints, meaning that at least 2 HID interfaces, likely one of audio control, and it's one for audio control, and another for backlight control. Alright, the Windows shell script reveals exactly how brightness is transmitted. It sends a check the feature report into it's setting a report, the feature report, into these address. So this, we are gonna do that. So let's get all of our informations. So also get our fqc2.c. We're trying to do exact copy of these devices. So let's look at it. I guess the current implementation doesn't have future for interrupt endpoints, which the real hardware has. Let's go back and face mine and go to interrupt section. So we have endpoints. One for the descriptor, the interrupts. Yeah, we have 2 interrupt points. We have 2 interrupt points, for one for Aqua and one for. We need interrupt points. Right. I'm already in Pro. Alright, wait a minute. Where's our interrupt points? Alright, what it tells to collect the USB and kernel logs for HyperX Quadcast. Somebody's watching me now. Oh, that's great. Yeah. Right. The Windows PowerShell script is called when an 65 report writing brightness data at offset, then sending command via feature report address. The kernel command is functional by registering handling right. However, the Linux implement to interrupt seen in real hardware those handle. In summary, matches real device. Alright. We're gonna sign up. Sign in from another account. You gotta be fucking kidding with me, right? You gotta be fucking kidding. Right, wait a minute. I will log in. So we're going a bit down. There you go. There we go. Now we have our account back again. So add them. Or we could ask them how we could install our interrupt points. We could actually add by ourselves. So I'm just gonna let it in here and let's open a chat GPT. How interrupt points and HID devices are working and Linux kernel. trip points don't mean CPU interrupts. They refer to USB and Bluetooth interrupt endpoints, but a special kind of endpoint used by like the load latency small frequency data. This is how it works in Linux kernel. What kernel interrupt points? 4 transport types: to control, the asynchronous, and interrupt. So we're gonna do something like this. So can I add virtual interrupt? Can I add interrupt? One for input and one for output. Alright. Polling interval. Alright. USB endpoint descriptor. I'm doing a device for emulating a device. We need to add one input and one output port. USB endpoint. Alright. 10 milliseconds HAD function descriptor. Yeah, you know what? I'm not going to deal with that. Let's ask the verbosity. What's going on? Let's like this. Alright, USB endpoint descriptor. Let's go back in here and where we should add the bind, the QC defined function. So we need some structures here, and there you go. We could add that. USB endpoint descriptor. Alright. So how can I add them? USB device. Allocate and assign the endpoints. It's QC2 bind. Let's go there. Let's bind it. Allocate the endpoints. After your interfaces are assigned, you can use ESP autoconfig to pick. Alright. Where should we add that? I don't have any idea about that, you know. Assign descriptors, maybe we could add after that. Yeah, there you go. So let's open our kernel, cd, crcm later, get to and make. What happened? No such file or directory. Alright, I see that. What do we need? CMake, SC make. We also need to install Packline as Linux headers. Alright. So what else now? Mic. Alright. So we have an error in here. The FC2 has no member name AP out. Yeah, I see that. Let's go back into our structure and APN static struct. How about this one? USB endpoint descriptor. Endpoint descriptor. Input. Oh, it's gonna be a. Are we freeing it? No. AP out. So we don't have AP out. I don't know how I should add it. So let's ask the ChatGPT about that. Which I don't know. Oh, we are setting our names, yeah. Why didn't do that? How about that? EP out that address. We don't have address. Right now we have, so I guess we just delete that. Nope, we can't. Right now we load it. Now we can test if interrupt. All right. we gotta USB. Oh yeah, silver SH. Nobody's watching me. You're not gonna give me one. Right. Now let's see. It's watch noise now. There we go. That's great. So, well, seems like it's working fine. So let's go in here and let's compare. Yeah, also when I installed the OpenRGB, so OpenRGB devices. Can't find our device because there is no. So I think that our stuff is working fine. So we can close here and clean. Now missing interrupt points and correct details from your hardware feed emulation. Right. Oh, git name. Push it. Right. Let's go back into the OpenRGB. Where are we going? HyperX microphone controller. V2 the Quadcast 2S microphone. So G controller, detect, define, HyperX Quadcast 2 PID. Right. Oh, okay. Right. We're gonna go add this in here. Okay, there we go. Detect HyperX microphone V2 controllers. So we're gonna compile this, right? Yeah. Make, or oh, we're gonna make true builds, cd builds, cmake. Right. I don't know how we're gonna do that. OpenRGB get lab. Building. Compile. Debian. Alright. Fedora. I'll install these dependent CDs and watchdogs. Alright. Qmake. UDEV files are missing. Right. And we can make. It's gonna be taking a while, I think so. I want to ask that, should we change symbols step 4? Oh, it's just a name, yeah. HID device info. Register HRT. Detector.h. So we're gonna go there. And here's the definition. I want to get on the phases. Here's all the information about need to change DB top. Oh my god, it's using a lot. It's gonna take some while. So let's see, is it going to be work? Let's go back in here. So we have our detectors, and we have the microphone RGB controller. RGB controller for 2S microphone. 2S. and OS microphone. RGB controller. So we're gonna go at work device here. We're using soundcast 2, not 2S. So we have to change the classes. Love this thing going on. Somebody just watched my screen. Well, scan effect. Right on. And now for some reason. Wired. It's not detecting. Yeah, we have to add some stuff over here, which I don't know how. Fix the header file. There's a storm in. Oh, wait a minute. Which interface address we have to try it first? So let's go in here. Where was it? Let's save it. Interface, page, and usage. So go there in here. So we have PID. We're gonna choose the interface one, and the page will be the same, I think so. There's the page and the usage. We're setting page and usage coordinates. Yeah, I see that. Why? So alright, just don't do that. Just don't do that in here. So let's close here and controller detect. I want to add my device. Here's the where is our oh, we were using the system level OpenRGB. We don't get anything. That's weird. we're gonna lock M back again, so that was our string bus.